This is chapter 5.2, Exponential Functions and Graph Notes, part 3. If you're not watching this in Edpuzzle, you're not getting credit for it. Don't watch it through YouTube. Euler's number, that's how this EULER is pronounced. Euler's number is just like pi. It is an irrational number that the symbol pi stands for 3.14159, etc. Euler's number is E. It is another irrational number that is approximately 2.7182818284, blah, blah. It keeps going. I just didn't want you to think that the 1828 repeats, because it does not. Euler's number is very important when you get into engineering or if you start talking about continuously compounding interest. So, like every millisecond moment of every single day, compounding interest, that's when you use E, which we will get to eventually. But first thing I want to do is remind you of how to put E in your calculator, round each to 4 places using e to the x on your calculator. Here is our calculator. Now I want to point out to you that E is this little blue E right here. You'll have to use the second button to get to it. So second division sign gives you the E. And you just go to the third power and hit enter. There it is. Round it to 4 decimal places after that. So this is approximately equal to 20.085. And then this 5 does not round up because the 3. So you leave that as a 5. That does not round up. It just rounds down. Remember, if it's 5 or up, it rounds up. That's essentially it. So these are very, very, very easy. Number 8, it says e to the negative 0.0 or 0.23. So go second e, that's the second division sign, raised to the negative 0.23. Enter. There it is. Again, this does not round the 5 up. If the 3 was bigger than 5 or 5 or bigger, it would round up. So this is approximately equal to 0.7945. Again, that doesn't round up, but some of them will. The last one is going to be your turn. So I want you to put that e to the 1.5 in your calculator and see if you get the correct answer. Hopefully you got that right, and we are moving on to just graphing this in the calculator. So this says graph e to the x and e to the negative x. So I'm going to go ahead and go to y equals, clear out what I have here. I'm going to graph e to the x power. If I graph this, it just looks like another exponential function, which is true, and that's what happened, because really this is 2.718 blah 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 to the x. So in this case, your base is just e. We will look at these a lot. So it still looks like an exponential function. Here is my table to help me graph it. And now we've graphed the Euler's function, exponential function. Now, this one is y equals e to the x, still has an asymptote of y equals 0, doesn't cross or touch. Let's talk about y equals e to the negative x. Now, we did talk about the negative being in the exponent. This is a change in x, so this is a reflection over the y-axis. So really what you can just do is take the graph that we just had and reflect it over that y-axis. So it'll look like this. So now this is a decreasing function. All the functions we've looked at so far have been increasing. So our first one is increasing, our second one is decreasing. And if you want to see it in y equals, we will just, I'm going to second insert a negative here. And that matches our graph. You can look at the table and get some ordered pairs if you would like to. Just like that.